Inventory management system. Any inventory management system has two dramatically conflicting goals. One objective is that you want to maximize customer service by having enough inventory or plenty of inventory in your system, and yet you want to minimize your inventory investment. There have been advances in the understanding of inventory management system, and we have been able to achieve both in some way. But inventory management system must answer these questions. How much do you want to order or you want to produce? When you want to order or produce? What kind of safety stock you want to maintain? We will begin with a simple model. This model was developed almost 100 years ago and makes lots of assumptions, and some of those assumptions you can probably laugh at, but hey, those are the assumptions. We always begin with simple assumptions, and we make the model more complex by relaxing those assumptions and making them more realistic. So let's look at the assumptions under Basic EOQ Model, Basic Economic Order Quantity Model. Demand is known and constant, and it's uniform. That means you know how much you're going to sell or how much you're going to consume and at what rate, and the rate is constant. So it is going to be depleting at a constant rate. Shortages are not allowed. You will never have a situation where you don't have any item left. Your orders are going to be timed to arrive just before you run out of your items. Lead time for the order is known and it's constant. Lead time is the time that elapses between the placement of order and the receipt of the order. All of your orders, they arrive at one instant. They're not delivered in slowly in different quantities, but they all arrive in one go. And there's no quantity discount whether you buy one item or you buy two items. Whether you buy one or two, it doesn't matter, or 20 or 2,000, you get to pay the same price per unit. And the cost of ordering does not depend on the size of the order. Whether you order one item, you'll pay same amount of money, or whether you buy 10,000 items, you pay the same money. And it incorporates the cost of placing an order, but also maybe the shipping cost is included in the ordering cost. So let's look at an example, a simple example, so you understand what it is. You begin with some quantity Q, and that quantity is depleted at a constant known rate. And as soon as it goes below some reorder point known as R, an order will trigger, and you will continue depleting these items. And as soon as your quantity on hand becomes zero, the next shipment of quantity Q arrives at that very moment. And the cycle continues in this fashion. Notice each of these periods, they look like a sawtooth, and therefore the basic EOQ model is also known as the sawtooth model. Let's take a numerical example and help you develop formulas and understand how these formulas are derived. We'll begin with a simple example. This is Office VR Inc. carries thousands of products. We are concentrating on only one item, which is a legal notepad. And for that, we are going to make these assumptions. Notice this table. I'm giving you some information on the left side, the values, and the right side is general expression. Really, I'm interested in the right side to help you develop the formulas and general expressions. So let's assume that the demand for these legal pads is 10,000 units. You're going to sell 10,000 units of these legal pads. And when you buy from the wholesaler, it costs you $3.50. And cost of carrying is 20% of your purchase price. So 20% of $3.50 is 70 cents. What is that number? That 70 cents means if you hold one legal notepad in your inventory for one full year, it's going to cost you 70 cents. Okay. Ordering cost is estimated to be $6.90. All right, so let's look at the general expressions. D is the annual demand, 10,000. P is the purchase price. H is the holding cost per unit per year. If you hold one item for 1 year, it is going to cost you H dollars, and it is expressed sometimes as a percentage of purchase price. In this example, it is 20% of P, or I times P. Ordering cost is expressed by S. Now let's see what the company is doing. At this point, company is ordering 500 units of legal pad every time they place an order. We don't know if this is the optimal quantity, but this is their current practice. That order quantity is known as Q. Our ultimate goal is to determine what is that optimum Q. Keep that in mind. So looking at the current practice, they order 500 quantities, they deplete it at a constant known rate, it becomes 0, the next shipment of 500 quantity arrives, and you continue in this fashion. Question for you is, what is the average quantity you are holding during each cycle? Well, you begin with 500 items, you end up with 0 items at the end of cycle, and therefore the average inventory held during that cycle is 500 plus 0 divided by 2. Or if you want to think about it, for some moment you held 500 items in your inventory, some moment you held 0 item, some moment you held 499 items, and some moment you hold 1 item. So if you average those things, time-based average, it will be 250. 499, 1 averages 250. 498, 2 averages 250. 497 and 3 averages 250, and so on. So on an average, you are holding 250 items throughout the cycle. And each cycle you are holding 250 items on an average, which means on an average you are holding 250 items throughout the year. Okay? So continuing with the example, what is the average inventory level? 500 divided by 2. And therefore, the general expression is Q divided by 2. Remember, quantity that they are ordering every time is 500. That's only to help you understand what is the current practice, but general expression is Q divided by 2. So, if you hold one item for 1 year, it costs you 70 cents. So if you hold 250 items for the whole year, it is going to cost you 500 divided by 2, which is the average inventory times 70 cents. General expression is Q divided by 2 times H, or simply rearranging the terms gives you QH by 2. How many orders will they place per year? In this example, they place order for 500 quantities, and they are buying 10,000 items, so 10,000 divided by 500 will give you 20 orders. They are placing 20 orders per year. General expression will be D divided by Q. D is the annual demand, Q is the quantity they are ordering every time they place an order. In this example, remember the cost of placing an order is estimated to be $6.90. So 20 orders times $6.90 will give you $138. But general expression is going to be D divided by Q, the number of orders, times S. Or rearranging those terms will give you DS over Q. Annual inventory cost includes 2 components: annual holding cost and annual ordering cost. And the general expression is AIC is equal to QH by 2 and DS over Q. Now pause here for a second. If the company orders all 10,000 items in one go, how many orders will they place? Only 1. They will place fewer orders, but they will hold more inventory. So their holding cost will go up. So as you increase order quantity, holding cost goes up, but ordering cost goes down. Your aim is to find out what is the optimum level of inventory that minimizes the sum of annual inventory cost. By the way, there is another expression which is total cost. This one includes AIC plus the purchase price. And this will be useful when we are looking at quantity discount model. Look at this expression, QH by 2 plus DS over Q. As I mentioned, as Q increases, holding cost increases, but ordering cost decreases. You buy more at a time, you will buy fewer times per year. So ordering cost, you will save on that, but holding cost is where you will increase holding cost as Q increases. Again, Q is in the numerator for holding cost. As Q increases, holding cost increases. Q is in the denominator for ordering cost. As Q increases, ordering cost decreases. And we want to find out what is that optimum order quantity. As Q increases, the annual ordering cost decreases. If you add these costs up, your total annual inventory cost may look something like a U-shaped curve where the minimum occurs at the line drawn there. Do you see that line at the bottom of the U-shaped curve? At that point, at that quantity, you're minimizing your total inventory cost. You will also notice that at that point, annual holding cost and annual ordering cost are equal. It happens in this particular case. We can figure out the optimum Q. How? At optimum Q, at the special Q, annual holding cost and annual ordering cost are equal. So we set up QH by 2 is equal to DS over Q and rearrange the term and solve for Q algebraically will give you Q is equal to 2DS over H. That's how you figure out the optimum quantity. Let's assume that there are 250 working days and therefore the average daily demand is going to be D. That is calculated as 10,000 divided by 250, which is 40. So the average daily demand is 40. A general expression for that is going to be D is equal to annual demand divided by number of periods per year. So we are talking about daily demand, you divide it by whatever is the number of working days. If we talk about monthly demand, you will divide it by 12. If it is weekly demand, you will divide it by whatever is the number of working weeks, 50, 52, whatever that is in your specific situation. Suppose the lead time is 3 days. That means if you place an order now, it will arrive exactly in 3 days. So what will be the demand during lead time? 40 per day, 3 days of lead time, 40 times 3 is 120. General expression for demand during lead time is D times L. Assume safety stock is 20. Companies like to maintain some safety stock. If there is fluctuation in demand, if the demand is not constant, or if there is a variation in lead time, you want to maintain some safety stock. And in this example, we are assuming that safety stock is 20, and therefore your reorder point is going to be whatever is demanded during the lead time plus your safety stock. So as soon as your quantity on hand becomes 140, you should place an order. And general expression for that is SS plus D times L is the reorder point. I would like to talk about safety stock a little bit. Safety stock is a function of variability. If your variability is high for lead time, sometime it takes 1 day, sometime it takes 10 days, obviously your safety stock has to be higher. Same is true about daily or periodic demand. If the demand fluctuates a lot, someday you're selling 20, someday you're selling 80, there's a lot of fluctuation, your safety stock has to be higher. So safety stock is higher if there's a lot of variability. So one way to control safety stock is reducing those variability. That's one way that you can reduce your investment in inventory if you can reduce variability. At this point, I would say pause the video and calculate all the EOQs and annual holding cost if you were using EOQ as your order quantity, annual ordering cost, inventory cost, and total cost. All right, so we are ready for calculation. We know the equation for EOQ is 2ds over h square root of the whole quantity. And for the office VR example, it's going to be 2 times annual demand 10,000 times ordering cost of $690 divided by 70 cents, which is the holding cost. And when you do this calculation, you will get 444.0072. Of course, we are talking about pads here, which is a discrete product, so we need to round it off to 444. Using this Q now, we know the average inventory level is going to be 222. If the company knows what is the economic order quantity, why should they be using anything different than the economic order quantity? So if you use economic order quantity, your average inventory level is going to be 222, as if you're holding 222 items with you all the time. How many orders will you place at this point? The equation is D divided by Q, which is 10,000 divided by 444. That gives you 22.52. And there's no need to round this off. This is 22.52 orders per year on an average. Some year it will be 22. Some year it will be 23. On an average, there will be 22.52 orders per year. Annual holding cost, the formula for that is QH by 2. And plugging in all the values, you will get 155.4. By the way, without doing the next part of the calculation, I expect annual ordering cost to be the exact same number. So let's go ahead and do it. Annual ordering cost is DS over Q. D is 10,000, S is 690, and Q is 444. And you do the calculation, you get 155.405. There's a slight difference, and that is due to the rounding off error. Okay, so this should be easy. So you know how to use this kind of formula to answer a variety of questions. Now you're ready to answer these critical thinking questions. So pause the video again and answer these questions. Remember, the diagram of annual inventory cost, annual ordering cost, and holding cost that we looked at before is going to be very useful as you answer these questions. So go ahead and pause the video. All right, so you read the problem, and let's start putting up the values for each parameter. So what did you say for D? Is it 250? No, it's not, because that's monthly demand. So don't forget to convert that into annual demand, which is 250 times 12 months, and therefore the annual demand is 3,000. Holding cost is given to you as 120 per stapler per year. Ordering cost is $50 per order. So given that, you need to figure out EOQ, which is 2ds over h square root of the whole quantity. And you can plug in the values from there. 2 times 3,000 times 50 divided by 1.2. And when you do the calculation, you will get EOQ of 500. Now that will be the Q you will use for the rest of the parts of this example, because you know what this optimum quantity is, and you should not be using anything other than this Q. Many of you may be tempted to look for a different Q. Remember, when I was explaining the development of those equations, I just made up a number to make it easier for you to understand. So you will not be looking for a Q. This EOQ is going to serve as the Q. Annual ordering cost, the formula for that is DS over Q. And again, now you know this EOQ or Q is 500. You plug in all the values, and you should get 300. Annual ordering cost is 300. Annual holding cost, by the way, is going to be the same. If it is not, then you know that you are making a mistake. And why it is going to be the same? Because this is the EOQ for which you are calculating annual holding cost. So let's go ahead and confirm. The equation is QH over 2. Plug in the values, 500 times 1.2 divided by 2. that is 300, and therefore you will see that both the values match up and you're in good shape. Next, we want to know what is the time between orders. Well, you have to play around with it a little bit, do some thinking. You know that your daily demand is 10 per day. Why? Because your annual demand is 3,000. There are 300 working days, so you need 10 units per day. Now, each order is worth 500 units, so that should last you for 50 days. 10 units per day, 500 units will last you for 50 days. That means time that must elapse between consecutive orders should be about 50 days. So, number of orders per year is equal to D over Q, which should be 3,000 divided by 500 equal to 6. So you will be placing 6 orders per year, and each time you place an order, it will be for 500 quantities. Hope this helps you understand the application of EOQ formulas that we have developed so far. That gives you some idea about basic EOQ model. Let's talk about some of the important practical considerations. Number 1, make sure that you do not reduce the lot size just for the heck of it. You're not going to increase your inventory service level. What will happen is that you will be converting your production time into setup time. If you reduce the lot size, you're not going to gain much. In fact, it will be detrimental. So the first thing that you want to do is you want to reduce the setup time. We will give a more thorough treatment on this topic when we discuss lean and JIT. But remember this, if you produce in smaller batches and you're making different kinds of things, you will be switching over from product A to product B to product C. If you cut down the setup time, if you don't cut down the setup time, what will happen is you will make fewer of A, then switch over and make something else. You will spend a lot more time on setup than on actual production. Optimum lot size is a fine balance between the cost of changeover and the inventory cost. So if you reduce setup time, you can produce in smaller quantities and cut down your cost. The other thing is that you have to have better forecasting, and if you do that, you should be able to reduce safety stock and therefore inventory cost associated with holding the inventory. Please understand, if you can cut down the variability in lead time, if you can cut down the variability in demand, which sometimes is not possible, but if there is any way to influence demand so that you have less variability, if you can achieve those things, your safety stock will go down and you can run your system in a smooth fashion. The last consideration is that please do remember that the U-shaped curve that you saw tends to be flat. Therefore, if you move away from the economic order quantity on either direction, the penalty is not high because your cost doesn't tend to increase rapidly, which is a good thing, but still the EOQ model tend to serve well the purpose of your planning.